Based on scientific research, it seems merging stars could explain massive black hole collisions and prove the existence of dark matter. Based on the observations of these astronomers, it seems like they have discovered that the heaviest black hole collision was produced by the gravitational wave GW 19521, and that this might actually be something even more mysterious: the merger of two Boson stars. This would be the first evidence of the existence of these hypothetical objects, which are candidates for dark matter. They also believe that dark matter comprises 27% of the mass in the universe. Gravitational waves are ripples in the fabric of space-time that travel at the speed of light. These gravitational waves originate in the most violent events of the universe, carrying information about their sources. Since 2015, the two detectors in the United States and the Virgo detector in the Cassina regions of Italy have detected and interpreted gravitational waves. To date so far, these detectors have already observed around 50 gravitational wave signals. All of these gravitational wave signals originated in the collisions and mergers of black holes and neutron stars, which allows physicists to deepen their knowledge about these objects. However, the promise of gravitational waves goes much farther than this, as these should eventually provide us with evidence for previously unobserved and even unexpected objects, and will shed some light and give further understanding on how current mysteries like the nature of dark matter can be unraveled. In September 2020, the LIGO and the Virgo collaboration made an announcement to the world that a gravitational wave signal GW 19521 was the signal that was consistent with the collision of two heavy black holes of 85 and 65 times the size of the Sun, which produced a final black hole with 142 solar masses. The resulting black hole was the first of a new previously unobserved black hole family, intermediate mass black holes. This discovery was of paramount importance, and as such, black holes were the missing link between two well-known black hole families: stellar mass black holes that form from the collapse of stars, and supermassive black holes that exist in the center of almost every galaxy, including that of our Milky Way galaxy. This discovery also presented an enormous challenge for astronomers. Their issue was to look at how stars live and pass away. Of course, the heaviest of the colliding black holes, which are 85 solar masses, could not form from the collapse of a star at the end of its life, which opens up a range of doubts and possibilities about the origins of these type of black holes. It was recently stated that the collision of these two objects, known as Boson stars, which are one of the most likely candidates to explain dark matter. In their analyses, the team was able to estimate the mass of a new particle constituent of these stars, an ultralight boson with a mass billions of times smaller than electrons. The research team did comparisons of the GW 19521 signal and that of computer simulations of boson star mergers, and discovered that these actually explain the data slightly better than the analyses presented by LIGO and Virgo. The result implies that the source would have different properties than stated earlier. Colliding black holes are still something that they will continue to discuss. However, it eliminates the issue of dealing with a forbidden black hole. Boson star mergers are much weaker. Therefore, they tend to infer a much closer distance than the one estimated by LIGO and Virgo. This leads to a much larger mass for the final black hole, of about 250 solar masses. So the fact that they have witnessed the formation of an intermediate mass black hole remains true. Boson stars are objects almost as compact as black holes, but unlike them, do not have a no-return surface. When boson stars collide, they form a boson star that can become unstable, eventually collapsing into a black hole and producing a signal consistent with what LIGO and Virgo observed. Unlike regular stars, which are made of what we commonly know as matter, boson stars are made up of what we know as ultralight bosons. These bosons are one of the most appealing candidates for constituting what we know as dark matter. The research team also uncovered that, based on the analysis, it tends to favor the merging black holes hypothesis. A boson star merger is actually preferred by the data, although quite non-conclusive. The results show that the two scenarios are almost indistinguishable given the data. Although the exotic boson star hypothesis is slightly preferred, this is quite intriguing, since the boson star model as of now is very limited and is subject to major improvements. A more evolved model may lead to even larger evidence for this scenario and would also allow the researchers to study previous gravitational wave observations under the boson star merger assumption. Like, comment, share, and subscribe. Thanks for watching. Be safe and goodbye.